everyone, welcome to GEMCHEM. Now today's video is on alkenes part 11 video, and here we are going to deal with application of hydroboronation of alkenes. Now in the previous video we have discussed in details what is hydroboronation of alkenes. You can watch it. I will give the link in the description box as well as the I button present above this video. And also already there are 10 videos of alkenes dealing with the different topics for alkenes. You can watch it also in the channel. So I will give the link in the description box as well as the I button present above this video. Now if you are new to GEMCHEM, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. Now first application is oxidation to yield an alcohol. So now previously we had dealt with oxymercuration and demercuration where we had obtained alcohol, but the alcohol was never a primary alcohol, that is terminal alcohol also is not obtained. But using hydroboronation, we can yield an alcohol which is terminal. So this is the importance of this application. Now when a trialkyl boron is treated with hydrogen peroxide, which is an oxidizing agent, under alkaline condition we get an alcohol. So we know the first step and this step is new, that is we are getting an alcohol. So what is the mechanism? Let us see. Now first thing is that in alkaline condition, hydrogen peroxide breaks up, because the OH minus abstracts a proton from this part. So this gives us ultimately O minus OH plus this H2O molecule. Now this is a good nucleophile, but this is a poor base. Why is it a poor base? Due to the alpha effect, that is this negative charge on this oxygen makes this hydrogen and OH minus to be a poor base, that is this part becomes a poor base due to the presence of negative charge on oxygen. Now next step, we take a trialkyl boron, that is like this, and our nucleophile, which is this one, and this nucleophile attacks the boron. So this attacks the boron. So ultimately what we obtain is like this, that is B, R, 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 and this O, O, H. And since there is extra charge on boron, so it is negative. Now the R group migrates to O and this OH gets away. OH minus is a good leaving group. So OH minus is being lost, minus, right? Now what comes ultimately? Let us see in the next page. We obtain this one, right? That is R, B, R, O, R, right? And we have a OH minus released. Next, this continues, right? So again, we have another O, O, H minus, and this will get attached to this one. So this will become negative charge. So again, this will migrate to this, another OH minus will get away. So this process continues for 2 times, 1 time and 2 times. Then ultimately what we obtain is like this, R, O, B, O, R, O, R. That is 3 alkyl groups are being replaced by OR due to migration of alkyl group. But this migration takes place, the migration which is being seen here is taking place by retention of configuration. So this is important. That is, if it is coming from back side, or if this group is present in the down portion, then it will get attached to oxygen from the down portion. Or if it is present in the up portion in the plane, then it will come in the up portion. So this stereochemistry and retention of configuration is being maintained. Next, we do hydrolysis by OH minus. This step is known as hydrolysis. So in hydrolysis we get 3ROH plus BOH whole 3. That is, from this part it gets cleaved and this hydrogen comes here to form ROH, and other OHs forms bond with this boron to form this product. So ultimately get an alcohol and BOH whole 3. Now here what are the important things which we have considered? Retention of configuration. Now retention of configuration can be seen from this example. Now in first step, boron is getting added from down portion, and when OH minus is coming, that is alcohol is formed, it also gets formed from the down portion wherever the boron is being present. So there is a retention of configuration. We can consider it as a syn addition of water, as if like a water is being added to this alkene, but actually it is not so, right? It involves so many steps and it is regioselective and appears to be anti-Marconic of type. It appears to be, right, because it's not directly anti-Marconic of type. And using terminal alkene, we get a terminal alcohol. So say this one, if we take this one, we will get a terminal alcohol. Whereas in case of oxymercuration and demercuration, we would have got a secondary alcohol. Similarly, for the last example also, we can see that we are getting a terminal alcohol. Now, with unhindered trialkyl boron, carbon monoxide can react at 125 to 150 degrees Celsius at atmospheric pressure to form an intermediate which reacts with alkaline hydrogen peroxide to yield trialkyl carbinol. So what does it mean? It means that if we take a trialkyl boron and react it with carbon monoxide in presence of the solvent, that is CH2 and having two OH groups, and diglyme, that is this one, and then on further reaction with oxidizing agent which is peroxide, then we get this type of moiety which is a trialkyl carbinol. So this is very important to understand. Now what is the mechanism for this one? So let us see the mechanism. We start from here, right? On addition of CO, we obtain such a moiety, that is, this is R and this is also R, and we are left with C triple bond O minus, and boron has a negative charge. Now what happens? Same case as the previous one. This R migrates to carbon and this bond opens up, right? And when this bond opens up, what we get? We get a different product or different intermediate, to be very specific. So here B, here also R, and we are getting O. So O is having one lone pair plus another lone pair which is coming from the breakage of the bond or the just release of the bond, that is this portion, right? For this one we are getting another lone pair. Now the R which has migrated is present here. Now what will be the next step? The next step will be another R will migrate to this carbon and another bond will open up, and this lone pair will get attached to boron to satisfy its valency, since boron has 3 valency, right? Now in the next step what we are getting? Let us see. Now in the next step we obtain such a thing, that is, here is a B, here is a C, and there are 2 R's which have migrated, and here is the oxygen and this is bonded. Now next step what happens? This R again migrates to C and this bond gets here. So ultimately we get like this, that is B double bond O and this one C R R R, and this one next comes here as if like this, that is, see here it becomes like this, O C R R R. Now this portion where it is coming from, if you understand it carefully, then one oxygen is present here and there is lots of presence of oxygen in OH minus H2O2. So this is coming from there. We will elaborate this step in the later cases. Okay. Now next part is, see this one, this will come here, R C R R OH. This is ultimately obtained when H2O2 is added under alkaline condition, presence of OH minus, right? Now in the next one we see few examples. If we see this one, first hydroboronation is done, then CO is added and then H2O2, so we get this kind of alcohol, trialkyl alcohol, right? Since the boron contains these 3 groups, so the alcohol is containing, the carbinol specifically is containing these 3 groups. Similarly for this one, now in this case what will be the boron formed? If we see specifically, then the boron will look like this. If we draw it very carefully, then this will give one bond and then this, and this will ultimately be getting converted to this one. Okay. Now second one is non-catalytic method of reduction of alkene to alkane. Now in this method, first is the hydroboronation, and on adding acetic acid there is a complete conversion to alkane. So this is a useful reaction, and here we will deal with the mechanism. So first we see that acetic acid CH3 C double bond O OH plus B R R and R. So these gets joined to give us such a thing, that is, this is suppose methyl group and C double bond O B R R and R, and here OH, and this is positively charged since boron is getting attached. Now this bond will go to this side and one R will migrate to the H center and this H will give up to O. So ultimately what we obtain, let us see, we will obtain C double bond O CH3 O B R and R, and this continues just like previous examples, so on, and we obtain it as 2HR plus CH3 COO whole to B. Now this can continue for 2 times, okay, not more than 2 times, and there are lots of examples about it. You can check the books for the examples, right? Now we'll go for the isomerization of alkyl borons. Now this is done when alkyl borons is heated at nearly 160 degrees Celsius. It undergoes rearrangement to yield an alkyl boron where the boron becomes attached with the terminal carbon, right? Now it occurs as hydroboronation is reversible and it is a way to convert internal alkenes to terminal alkenes. Now when we see the examples, it will be clear. So let us see. Now first example, if you see the boron part, that is the boron moiety is present here, and on heating at 160 degrees Celsius it is present in the terminal part. Similarly here it is present and attached to the ring, whereas on heating it gets attached to the terminal end, right? So what is the mechanism? So we will see the mechanism for this first one. So let us see. Now if we consider this like this, similarly as shown, B, and these are the 2 again. Now what does it mean, this one? This means that here also this moiety is being attached here as well as here. So this is the basic meaning for this. Now this on equilibrating breaks up. The boron portion gets break. Now this will give us this alkene plus the boron moiety with the other 2 groups, and here a hydrogen, right? And in the next step what happens, we can see that it can join anywhere. This will give, suppose this one, it is coming and getting attached to this particular carbon. If we draw like this, that is boron, and these 2 are present, then this. Again in the next step what happens, it breaks up. Suppose it is breaking like this, that is this, and same thing, but here the alkene and the boron moiety present here. And in the next step, this boron gets attached to the last carbon, that is terminal carbon, right, to give our desired product. So this is how simply it is occurring. So we can simply get it by 2 or 3 steps. So this was our original molecule. It breaks up to give alkene and the boron moiety, whereas after few times it will again join and give this one. Then it will also break to give this one, and ultimately our product. Okay, so this is important. Now we had told that here it is a way to convert internal alkene to terminal alkene. So how is it possible? If we see for this example, so how to convert this one? This is very easy. Now the steps are that internal alkene is first treated with P2H6 and THF, then it is heated about 160 degrees Celsius to obtain the alkyl boron, in which the boron is attached to a terminal carbon, and next it is isomerized alkyl boron is heated with another alkene of boiling point higher than 160 degrees Celsius. So we get the terminal alkene which is being distilled off. Now let us see first and then I will explain each and every steps. Now see this one. This one is reacting with P2H6 in THF. Okay, so we are getting the boron like this, B, and here are the 2 same groups. Next we are heating it at 160 degrees Celsius. Now what we will obtain? We will get the isomerized product. So it will be like this, and here is the boron, and here is one group, and here is another group. Now in the next step, what we will see? Now in the next step, we are going to react it with nearly 160 degrees Celsius, but a alkene is being required with the boiling point greater than 160 degrees Celsius. So oct 1 in is one of those which can help us to obtain the alkene. So this causes formation of this boron. That is, here we get this one. This alkene is being obtained, plus the boron is being obtained with a hydrogen, and also another boron is being obtained of this particular alkene, that is this one. Now what is happening here? Let us see. Now this steps are clear, right? We have seen the previous mechanism in the previous slides. So in the next step, this alkene takes up this boron from this alkene particularly, that is this alkyl moiety, and makes it an alkene moiety, and this itself becomes a boroalkane, that is alkyl boron moiety. Okay, so this is a rare exchange. Now the next one is this one. This is a question, right? How to solve it? Now let us see what is being occurring here, right? So first here the CH3 group is being converted to CH2OH. So we know how to convert it. We have seen. And the next one, it is converted to a alkane moiety. So we have already seen how to convert it to the alkane moiety, but we do not know how alkene is being converted to alcohol or alkene is being converted to alkene. But here it is given alkane, right? So first here we will write what we know and what we do not know. We know how to convert alkene to this and to this, right? But here the question is given as alkane. So how to convert alkane to alkene, and then next undergo this conversion. So let us start doing. First, what we will take? We will take the alkane. So this is our alkane. Now if we react it with bromine, we have seen in the alkane video how bromination is being done. If you have not watched it, you can watch it. I will give the link in the description box as well as the I button present about this video. So on bromination, it gives this one. That is, here a Br comes and here is our Me, that is CH3 present here. Now if we add ethanolic KOH, then we are going to obtain a alkene, and this is the target portion which will help us to get to the hydroboronation and then to the alcohol. So we know the steps B2H6 and DHF, right? And then we get the important thing which we require, that is this alkyl boron. This is a CH3 and here is our boron B, and here same moieties are being attached. In the next step, we would require to boron to come, in which portion? We require the boron to come here in the terminal portion. So what is the method? It is heating by 160 degrees Celsius. So ultimately we get this, that is, here is the CH2 and here is boron attached. And in the last step, we require two things to be done. First, from this boron we can use H2O2 and OH minus to obtain the alcohol, that is this one. This is our first target. And in the second place, we can add CH3 COOD, that is the case where we are getting alkane, to get this one, that is this product, right? So whatever things we have done in this whole video is a summary for this synthesis. So if you can see here, we had previously dealt with hydroboronation, so we have done here hydroboronation. In the next step, we have dealt with the isomerization, and here we have dealt with oxidation to yield an alcohol, and in this step we have dealt with conversion, that is non-catalytic method to convert alkene to alkane. So this much for today. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment.